So here we go for the Edexcel Higher GCSE paper. It's from the May-June 2024 series, and as you can see, it's paper 1, so no calculators allowed. So question 1, we have an nth term question. It's arithmetic, it's going up by the same amount each time, and as soon as you spot it's going up in 4s, jot down your 4n. And then start having a look at the difference between your 4 times table and the sequence you're given, and you'll see that each time it's subtract 3. On we go. So question 2, pretty standard fractions. Much prefer not doing the 3 minus 1. Always think you're better off preparing for all kinds and turn it into an improper fraction. So big times bottom is 15, add the top. Big times bottom is 3, add the top. And what's the LCM, lowest number that 5 and 3 go into? We're going to turn them into 15ths. Left hand side, treble the top and the bottom. In goes a 57. Right hand side, times everything by 5. And now we can simply subtract the numerators. So 57, take away 25, gives us 32. We'll turn it back into a mixed. 15s into 32 goes 2 with a remainder of 2, and we keep the 15. Next one, it's only worth 1 mark, so it's always going to be something simple. It's not quite the easiest of spotting in the world because it happens right at the end, not at the start. It's that final step there. If Kevin was attempting this question, he's done everything right at the beginning. All he's done is here. You're supposed to go how many times does 24 go into 35, and it's supposed to be 1 remainder 11 instead of his 9 as the numerator, so any words or whatever to that extent. Number 3, I've already started by putting the horizontal line on, because as soon as you see some keywords, plans of a floor and covering, you've got to straight away, don't read on. Or as always with wordy questions, whether it's higher or foundation, just do the basics. Get some easy marks ticked off, and I would say easy marks would be the area of the larger rectangle, and the smaller rectangle is 6, and 8 minus 5 to get 3. So we have a total area of 68 meters squared. So Petra has 3 tins of paint, 2.5 litres. So we treble it. So she's got 7.5 litres of paint, and she thinks that 1 litre covers 10. So that's what she thinks. So when you compare the 75 and the 68, yep, she's got enough. I'm staying here while I answer part B, because part B mentions that in actual fact each litre covers 11 meters squared. Does that fact actually change your answer? And the answer is no. She's still got plenty of paint. In actual fact, if you want to do it numerically, she's got 11 times 7.5. In other words, she's actually got 82.5 litres, or just do it in words, as in she's got more paint than she thought. She can still carry out the job for obvious reasons. On we go to the Venn diagram for question 4. So we've got the complement of P, that means outside of circle P. So that just means don't write down the 12, the 15, and the 18. You can write them in order. I'm not a fan, just in case I miss any out. Don't like to cross them out in case they're used for a later part. But there we go. Find the probability that a number chosen is in P union Q. So the first thing is there are 9 numbers in total, 5 inside the circles, 4 outside. P union Q means both circles together including the overlap. And there are 5 of those. Job done. On to number 5. Keyword when you read through a question. In this case, it's estimate. So as soon as you reread the question, get rid of that 513. It's 500. Driving 500 kilometers every 10 kilometers means she's doing 50 lots of those journeys. And 50 times 0.8, not 0.81, we're estimating, or 5 eighths of 40. So 50 80s, 0.8, sorry, are 40 euros. So, is your answer an under or an overestimate? It's under. All right, because we've rounded the amount of kilometres down. So the actual answer is going to be 41, something like that. Number 6. I've already drawn on quite a large triangle, the largest one that sensibly fits on. You could have drawn one much smaller like so. Doesn't matter. I always prefer to draw the largest one possible because it's better habits for when you're estimating the gradient of a curve. So find an equation for L. So it's going to be y equals sum x's plus c. C is always the easiest thing to identify. Stick it on the end. Gradient-wise, we refer to your triangle. If it's 3 high, it's 2 wide. Mixed fraction is fine. Decimal is fine. I'll leave it as 3/2. M is a different straight line, so anything parallel. So anything, as long as it's not a 0 on the end, I'll keep it simple. But any number on the end, plus or minus, would get that extra mark. Number 7, typical wordy going over the top. Keep your thoughts, keep your information organised. So we've got small, medium and large jars. Total of 400. 3/8 are empty. So let's go for another row. This is where we want the empty ones. So 400, we divide by 8 to get 50, times by 3. So we're only looking really at 150 of the empty kind. So for the empty jars, so going to keep this top line not really needed. Number of small jars to medium is 3 to 4. Medium to large is 1 to 2. That's nice. We've got an immediate connection, but keeping it in the same proportion, it's multiplied by 4. In goes an 8. And what that tells us is that we've got 3 plus 4 plus 8. We've got 3 different kinds of items, but we've got 15 shares. Each share is worth 10. So the small jars, small empty jars, are worth 30 out of the 400 jars we originally had at the beginning. Knock off a 0. Now it wants the answer as a percentage. To get it as a percentage, always handy to go over 100. 40 does not go into 100 very easily unless you know the old trick of multiplying by things like 2.5, 3.5 and so on. And this one's a 2.5, which means double it and add on half. 3 doubled is 6. Add on half gives you 6 plus 1.5, 7.5, and bosh, that's your percentage. Number 8. Length of 8 parcels, but it tells you that the mean of them is 2.5. Well, 4 lots of 2.5 is 10. So 8 lots of 2.5 mean we have a total weight of 20 kilograms. The mean weight of 3 of them is 2, so they'll have a total of 6. So the other 5 parcels goes into 14 kilograms. How many times? 5's into 40 goes 8 times. We have a 2.8 kilograms. Number 9, easier than you think. So don't forget, if you were wanting to reduce by 1%, your multiplier would be 0.99. Well, this multiplier is 0.70, so similar logic. It's losing 30 pence in the pound. It's losing 30%. Number 10. So on this one, you could make the x's the same. You could make the y's the same. I'll go for the y's. I'll take the top equation. I'll treble everything. I'll take the bottom equation and I'll double everything. And that tells us that the coefficient, the number in front of y, is not just 6, not just the same value, absolute value, but also the same sign. And we know from simultaneous equations, same sign, subtract. 15x take away 4x leaves us with 11 of them. The y's cancel out, and 69 take away 36 is 33, and dividing through by 11 means the value of x is just 3. I'll take equation 2 and rewrite it. It starts with 2x's, which is 2 3's. Take away 3y. How can we do a takeaway and it goes up? It's because the stuff we're taking away is a negative. And again, divide through by 3. The value of y is negative 4. Number 11, as you can see, I've already got a head start. But take it one thing at a time. It's first of all translated, so 6 right, 4 down. I just did some counting. I like to pick a certain point on the certain vertex, translate that, and off we go. And then with or without tracing paper, do it by counting if you want. That's your centre. I counted 2 down, 3 to the right, becomes 2 left, 3 down. And again, that's the same point. Describe fully how we get triangle A onto triangle C. So I'll use this circled point. How do we get from there to there? Well, it's definitely a rotation. It's definitely going that way, as in clockwise. And it's probably easy to see if you pick this corner. But how would that corner turn into there? Well, it would be a 90 degrees clockwise. But easier to tell, that would be the centre, because 1 right, 1 up becomes 1 down, 1 right. But again, you could have picked tracing paper, done it by trial and improvement, but no matter which way you've gone about it, worth spending some time on these. Negative 4 and 1 up. It's only 3 marks, well worth 5 or 6 minutes of effort to get those marks. Number 12, good old matching graphs. I always look at them and go, what shape will they be? Well, we've got an x squared. Positive x squared will be our old trough shape, and it's moved down 4 squares. So of all these, it can't be A. That would be a negative x squared graph, so it has to be H. Then we've got a negative cubic. Well, a positive cubic is that kind of shape. So a negative cubic is like a downhill roller coaster. So C is positive cube, E is positive cube, F is your negative cube. And for treble I, we don't care about the 5 on top. Absolutely nothing to do with that 5 because it's not drawn to scale. There's no markings on the axes. That 5 means nothing. We focus on the fact it's a reciprocal graph. So it's definitely not D, definitely not G. We've already used H and F. So which one of these? Well, B is the standard 1 over x reciprocal graph. So when we flip it upside down with the minus, that's what causes the right answer to be J. On we go. Obviously, because I'm rubbish with technology, I've done this already, but I will talk you through it. So whenever you're drawing a histogram, always make a column for widths. So simply do top boundary, take away lower boundary, and so on. Always think of frequency as area, and think of frequency density as height. So where's this column of numbers come from? You do area divided by width, 20 divided by 10, 70 divided by 20, or in other words, 7 divided by 2, 22 divided by 5, either good quality mental arithmetic or bus stop. That one's an easy one. 8 divided by 10 becomes 0.8. So when you're drawing them, make sure you use a ruler, take care to have, I always mark out the widths first, then mark on the heights, and off you go. Now part B says estimate the fraction. So you know that when it wants a fraction, look at how many people we're speaking about. It's 150. So we need to work out an estimate for how many people are between 20 and 40 minutes. And we can do that because that's a nice, your line be better than mine, but we've got to estimate that that's half that bar. The full bar is 70, so there's 35 in there. The next bar is all 22 people because it includes the whole lot. And the next one goes up to 40. So it's a third of the final bar. And the final bar is a nice 30. So there's 10 in there. 35, 45, 55, 65. We're getting 67 people as our best estimate between those limits. Number 14, expanding a cubic has to begin with expanding a quadratic. You can pick any two brackets you want, but I just go for the first one first. We've got 3x times 2x. 3x times positive 3 is 9x. Negative 1 times 2x is negative 2x, meaning our middle term is 7x. Negative 1 times positive 3 is negative 3. And obviously you could carry on with loops. Not a big fan of having 6 loops. So I'll go with the mixed approach of loops first, grid later. So we fill the top row in, multiply everything by x. 7x squared, negative 3x. And across the bottom, multiply everything by negative 5. So negative 30x squared, negative 35x, positive 15. Top left is part of our answer. Bottom right, part of our answer. They need to be simplified. 7 take away 30 is minus 23. And negative 3, negative 35 is a bigger negative, negative 38x. And on we go. So number 15, it's asking you to work out the area. So let's just work backwards, use a bit of logic. To find the area of a sector, it'll be pi multiplied by the radius squared multiplied by the angle, which I'll not fill in, over 360. So we need that angle. Where can we get that angle from? It's got to be from this fact, but it tells us that the arc length is 5 pi, so we take it back a step. The arc is 5 pi, and the way you work out the arc is 2 times the radius times pi, 2 pi r in other words, multiplied by, again, this angle. This time I'll call it x. Could fill it in there, not going to bother. Divided by 360. Now what we've got going on is we've got two lots of 6, that's 12. 12 over 360 is 30. The pi's cancel, and so x divided by 30 is 5, multiplying both sides by 30. We find our angle. And it's still non-calc, don't forget. So we can, but they've given us really nice numbers here. The zeros cancel, divide top and bottom by 10. And then look what we've got here. We've got 6 squared, that's 36 on top, 36 on the bottom. They too will cancel out, leaving us with just 15 pi centimeters squared. Number 16. A weird question. These one of those ones where it's, think of it as probability trees without drawing all the probabilities. We only want top. So if you go along the top in this situation, the probability of getting an orange multiplied by a second orange is going to be, well, probability of a success is n, and a probability of a success on the second one, n minus 1, out of all probabilities, or the probability of all outcomes on the first branch will be n plus 1. But then there's one fewer sweet in the bag, so we take away 1 from that, like so. And as you can see, what we've got going on is you've got an n up here and n down there. They will cancel out too, leaving us with an n minus 1 on top and an n plus 1 on the bottom. But really, the examiner wants to see those top bits lining up like so, with a multiplication in the middle. If you're familiar with rationalising, you'll know that the first one's just an easy one. You can just go straight to the answer with it only being worth 1 mark, but I will talk through it. Multiply top and bottom by root 7, so 1 root 7 on top. Root 7 times root 7 is root 49, also known as 7 on the bottom. When you're adding and subtracting, you can only add and subtract when they are like surds or the same order surds, whatever your teacher's been used to calling them. And that's your key step, because root 16 we know is 4. So it's like having 4x, take away 1x, leaves you with 3x, or in this case 3 root 5. Number 18. I'll do this the long way. What you could do, obviously, is add them as decimals and just do a single conversion, but I'll go for it the more straightforward but longer way. Reason why I'm preferring and going for this method is it's just good practice. You know that this is so common on the non-calc papers. If you don't revise for these, then you haven't revised properly. So you'll notice it recurs every 2 digits. So this is one of those where you just go straight for 100, which gives you the same recurring bottom take away top. So we've got x to be 15 over 99. Both are in the 3 times table, so divide top by 3 and bottom by 3. And just by peeking at the answer, I'm going to double the top, double the bottom. You can see a link already. The trickier one is the 0.227 recurring. So when you multiply it by 10, they all bump up 1. So you get 27 recurring. And when we now times it by 100 to get 1,000 y, that bumps them all up to 227.2727. And again, just like up here, when you've got the recurring parts repeating, you know you're getting there. So bottom take away top, 990y. Bottom take away top is 227 take away 2. And 225, these are not nice numbers. Let's divide top and bottom. Let's divide, say top and bottom, haven't got there yet. 225 over 990. So we can divide top and bottom. In this case, let's divide them by 10 and double. So on the bottom, 99 doubled. Divided by 10 is 22.5 doubled. Oops. You keep going with that because if we look again, they're in the 3 times table. Divide the top by 3. Divide the bottom by 3. And that was your connection. The 66 was very definitely a big clue in this one. So as you can see, you end up with 10 of something plus 15 of something. That'll be 25 of that something. Another word you can say M is 25 is an alternative way. Yeah, it's quite a long way, but I'd say 3 marks. Bit stingy that one, but never mind. So as you can see, I've got a little head start on number 19 because I hate when you've got overlapping shapes in particular triangles, whether it's a SOHCAHTOA question or an angles question or something like this. Never a fan. Always takes too much brain hurt and you just end up getting nowhere. Much better for me to draw them out like so. So we're told AB and AC, so those two, they'd be there on the original. And AD, that's that one, which is now here. And BD, that's the whole line, which is there. But the key is, if that's 4, that's 21. The whole lot, both sides, is 25. What we also know is B to C, the 4 is there. Now what we don't know is this side length there, A to B, but it does reappear there. Now we can set up a nice equation. We can say this big side divided by its corresponding side will be in the same proportion as this big side divided by its corresponding small side. Now if we times both sides by 4 times both sides by x, we get x squared is 100, and square rooting both sides gives us 10. Because we're dealing in lengths here, we obviously ignore the negative 10. Now that doesn't quite get us to the answer, but it does tell us that that's 10, or that's 10, depending on which way you want to go about it. But we're asked for the ratio of A to B, that's that distance there, that's the 10, to the ratio of, A to B ratio A to D. That's the 25. And we can cancel that down. Divide both sides by 5. On we go. So this one falls into the category of haven't quite seen one along the same lines, despite the fact you'll know it's an indices question. So let's take a look at this first part. Let's not read on. Now, when we have over, it means subtract, let's not forget. So, first of all, cube root is power of a third. Over means divide, and divide means subtract the powers. So we've got the first statement that x is n minus 3. Let's move on to the second part. 2 to the y. Square root is power of a half, and we've got power to a power. That's the power rule. We multiply a half by the 5. We get 5 over 2. So not only do we know that x is n minus a third, we also know that y is 5 over 2. And we're told this important relationship. So let's take that and sub in what we know. Let's replace the x with n minus a third. Let's replace the y with 5 over 2. And let's put that equal to 8. So obviously we can now just rejig things around. So let's take away 5 over 2 from both sides. That's 2.5. 8 take away 2 is 6. So it's 5.5. Or in other words, 11 over 2. We now add a third to both sides. I'll do a few things for the price of one at the same time. So 11 over 2. I'm going to treble the top, treble the bottom. I'm going to add a third. I'm going to double the top and double the bottom. And so, as you can see, we've got 33 of something plus 2 of something. We've got 35 of that something. Doesn't ask us to give it in a particular form, so I'll leave it as an improper fraction. So for number 21, not a fan of shape and space questions where there isn't a diagram, so draw a quick one. Doesn't have to be any good. And you can start filling in some information. Stick on the length of 20, stick on the H and W, and you can start filling in that the front will have an area of WH in any order, the right hand side 20H, and the top of 20W. We can start to link the two unknowns. So the first statement we write down is the volume of 300 is equal to 20 times H times W. Divide everything by 20H. We get 15 over H equals W. First important equation banked. We can now move on to the second bit in terms of the 370 for the total surface area. So for the total surface area of 370, we can basically double and add all the other sides, double the top, double the right, double the front. But we posh simultaneous equations. Let's rewrite that equation, but as we go, let's sub in, let's replace the W with 15 over H. So firstly, 40 lots of 15 is 600 over H. Nothing to change on the second term. There's no W. On the third term, the W gets replaced with 15 over h. H's cancel, leaving us with 30. Going to do lots of steps of algebra in one. The next one, going to minus 30 from both sides, get that sorted. Then going to multiply everything by h, and I'm also going to divide everything by 10. So the idea is the 370 ends up being 34 because you subtract 30, knock a naught off. This next term becomes just a 60 because don't forget we've multiplied everything by h, and the third term multiplying by h and dividing by the 10 gives us the h squared. Next thing, again, a couple of steps of algebra all in one. I'm going to rearrange to make 0. So I'm going to subtract 34h from both sides. But because everything's even, also going to divide everything by 2. When you factorise this, entirely your choice whether you want to do it by trial and error, AC method, or formula. I always like to just run through a few options in my head, but it's -5, -6, because -5 times -6 is positive 30, -5h, -12h gives us the -17h. So as I say, no matter how you get there, just get there. So that means we have a couple of values for h. It can either be 6 or here 2h minus 5, so that's got to equal 0, so it's going to be 5 over 2, or in other words 2.5. Now the idea is work out the height of the cuboid. The width is greater than the height. So in other words, one of these numbers is the height, one of these numbers is the width. Work out the height, that'll be the smaller of the two. So the height will equal 2.5 centimetres. On we go. So I've cheated a bit for number 22, already sketched it because I'm rubbish with technology, always have been. So the idea here is you'll get 1 for the general shape, not doing anything daft, but you'll notice the labels on the y-axis are also required for the 2 marks. The next bit, let's just divide everything by the 2. So it's giving us -1/2. Now this requires a bit of knowledge in that sine of 30 is a half. So when you've got -1/2, that's down here, the solutions are going to be there and there. So you're wanting these numbers here and here. So it's this bit of the distance is 30. So the distance there also going to be 30. And the distance below 360 also going to be 30. Not bad when you know it. One of those practice definitely will make perfect, using the lines of symmetry and so on for your sine and cos curves. So 23, it's another one of them shape questions where there isn't a diagram, so draw one, even if it's rubbish. So it's an equation of a circle, so your starting point needs to be x squared plus y squared equals the radius squared, which we can work out the radius with the fourth line down. It tells us that the coordinate 5, 10 lies on the circle. So application of Pythagoras, 5 squared, 10 squared gives us, adding them together gives us 125. So the root of that is the radius. We can take that now to the coordinates of Q. Q is 2 to the left and a certain amount down. So when we apply Pythagoras for a second time, the vertical, that's y squared, The horizontal, that's 2 squared, negative 2 if you want to be technical, but who cares? We're squaring it, equals the root of 125 all squared, or in other words, 125. Now if we subtract 4 from both sides, square root, we get 11, and it's 11 in the downwards direction. Diagram confirms it. Now you don't need another diagram, but I do like to draw one. Get rid of the circle and let's just focus on exactly what's going on. It doesn't have to be drawn to any particular scale. Just get to this point so you can see what's going on. Finding the gradient, not a bad idea. Where does the 21 come from? Well, vertically it's at 10 minus 11, so vertically that is 21. Horizontally is minus 2 to 5, so that's 7. And you're told that it's a positive gradient anyway, so you didn't have to worry about the possibility of negatives. So we've got the gradient is 3. Now I'm going to take the coordinates of P, y equals mx plus the intercept. But we know that when x is 5, y is 10. So replace y with 10, replace x with 5, subtracting 15, and it would have worked for q. I just avoided it because of negatives. Taking away 15 from both sides means us that the intercept would be negative 5. They happen to call the intercept k. At the end of the day, that's the right answer. So I hope that helps. I'll see you on paper 2 for the calculator work.